So exercise related to distance time and speed time graphs. You can also use a chat, mic or screen annotation to answer during the session. Figure 1.1 shows a distance time graph. So if it is a distance time graph, remember for a distance time graph, what slope represent? The slope represent the speed of an object. Describe the motion of each of object A, B, and C by selecting an appropriate description. First about A. When you see for A, what is happening? The angle is increasing. If the angle is increasing, what we can say, if, like for A, the angle is increasing, or we can say the slope is increasing. So if the slope is increasing, what we can say, we can also say the speed is increasing. So increasing speed is for A. What about B? For B, you can see it is a straight line with a constant gradient or a slope. So if it is a straight line with a constant gradient or a slope, so we can say B is, as the slope is constant or the angle is constant, the speed will also be, because the speed represents the slope represents the speed. So it means the speed will be constant. So B, it will have a constant speed. And what about C? For C, it is a horizontal line, means the distance is not changing. If a distance is not changing, what we can say? We can say object is at rest. So stationary or at rest, so C is the stationary. This was a distance time graph. But if we have a speed time graph, when we have a speed time graph, what the slope represent? The slope represents the acceleration of an object. So first, for D, you can see the angle is increasing. So if the angle is increasing, what we can say? We can say that, like for D, the slope is increasing. If the slope increase, so we can also say the acceleration is increasing. So D is increasing acceleration, so this one is D. What about E? E is a straight line. Whenever it is a straight line, means the slope is constant. If it is a straight line, shows that the slope is constant. And when the slope is constant, because it's a speed time graph, the slope represents acceleration. So we can also say the acceleration of the object is constant. So E is representing a constant acceleration. And what about F? F is a horizontal line, means the speed is constant or speed is not changing or slope is zero. So for F, the slope is equals to zero. Horizontal lines always have a zero slope. So when there is a zero slope, we can also say the acceleration is zero. So, and when acceleration is zero, means the object is not changing the speed or it is having a constant speed. So it will be F. Is it clear, this one, part B of question 1?
Yes, sir.
Okay. Moving on to the next question. A driver gives a student a sudden order to stop a car in a shortest possible time. Figure 1.1 shows a speed time graph for a motion of a car. Look, for example, if there's a driver and the instructor in the same car, when the instructor is saying a driver that stop the car, the driver will take time to react. Like he will take time to react and press the brake. As a result, what will happen? There will be like a distance, like the speed won't change for some time. Why the speed won't change for some time? As you can see here, even though the instructor give an order here, but the car does not change the speed, it will continue to move with a constant speed. Why the car continue to move with a constant speed even though the instructor give an order to stop? The reason is that because the driver, like once, for example, if you're driving a car and someone give you an instruction that stop the car, so you will take time to react. Instantly, it's not like you just press, you will take time to react. And when you're taking time to react, the object will continue to move with its original speed or a constant speed. So the first part, the order to stop is given at time is equals to 0 second. Like this is the moment, state the speed of the car. So what is the speed of the car when an instructor give an order to stop? Like this is the point the instructor give an order to stop. But what is the speed of the car here? Each box is 10 boxes equals to 10. So each box is 1. So there are 8 boxes above. So this will be 18. So speed of the car will be equals to 18 meter per second. And suggest why the car continue to travel at a constant speed, like for 0.9 second. What is the reason for that? The reason is that because of the reaction time of the driver will take time to react. So that's why the car will continue to move with a constant speed. Calculate the deceleration from 0.9 to 4 seconds. So how we can calculate, because it's a straight line, there are two ways to calculate that acceleration or deceleration. If it is a straight line, you have two options. It's up to you which one you find it easy, you can apply. You can use a formula for the gradient, or you can also use a formula for the acceleration or a deceleration. If you're using a formula for gradient, it is y2 minus y1 over x2 minus x1. Or if you are using a formula, that is the final speed minus initial divided by the time interval. Delta t means like the time interval, change in time. So it's up to you, because from 0.9 second, like this is 0.9 second to 4 second, it is a straight line. So we can use any of them. So if I'm using a formula, so acceleration is change in the velocity divided by time. What is the starting speed at this point? So starting speed at this point is 18 meter per second. What is the final speed at 4 seconds? The final speed is 0 meter per second. And what is the time interval? Like it was from 0.9 to 4. So how much? So this will be equals to 3.1, because from 0.9 it start to decelerate and it decelerate till 4 seconds. So that's a time interval, which is 3.1. So final speed, that is 0, minus initial speed, that is 18, divided by 3.1. So we'll get a negative answer, which is 5.8 meter per second square. So it is 5.8 meter per second square. So we can just write here 5.8 meter per second square. No need for negative sign, as they already mentioned it is a deceleration. So 1 mark is for writing a formula or using a gradient. That is 1 mark, and 1 mark is for writing the answer, like getting a correct answer. Then the distance traveled by the car from time 0 seconds to 4 seconds. So how to work out the distance traveled by the object? For a speed time graph, if we want to calculate a distance travel, so what we do, we use the area under the graph. Area under the graph gives us the distance travel. We can divide this into two parts, or you can use a trapezium. So one side, it is a rectangle, and the other side is a triangle. So use a formula for a rectangle. So that is length into width, so 0.9 multiplied by 18, because this is the height is 18 and the length is 0.9. And the triangle, it will be half base into height. So it is starting from 0.9 and ending at 4. So that's equal to 3.1. And the height is how much? It is 18. So we get the area of the triangle and we get the area of rectangle. So because we need the total, to get the total, we simply add them. So 0.9 times 18, that is 16.2. And 3.1 times 18 divided by 2, that is 27.9. This is 27.9 plus 16.2 equals to 44.1. So the total distance which is traveled by the object, this car, that is 44.1, and the unit, because the speed was given in meter per second, so unit will be meter. If the speed was in kilometer per hour and time is in hour, then the unit will be kilometer. Is it clear how we worked out the distance traveled by an object? Anyone having a doubt or a question in this? In question 3, figure 1.1 shows the axes which are used to plot the distance time graph. On the figure 1.1, draw a graph of an object that is moving at a constant speed. Distance time graph, the slope represents the speed. So if you want to represent a constant speed, means the angle should not change, so it will be a straight line. That is, and we label that as A. The second one, speed is decreasing. So if a speed is decreasing, it means the slope should decrease. That is B. Because the distance time graph, remember the slope represents the speed of an object. Here A was a straight line, constant slope, so constant speed. B, the angle was decreasing, so speed was decreasing. In part B, figure 1.2 shows an axis used to plot the speed time graphs. On the figure 1.1, draw the graph of an object that is moving at a constant acceleration. So speed time graph, what slope represent? The slope represent acceleration. So moving at a constant acceleration, so we have to draw a constant, like the line with a constant gradient and label that is S. And then when increasing acceleration means the slope should increase. So that will be T. In question 4, figure 1.1 shows a speed time axis of a graph of motion of a car. And see, it's a 5 marks and you have to complete a graph by using these information which is given here. The first, from time 0 seconds, like from a beginning till 15 seconds, the car has a constant acceleration to a speed of 28. So means the car reaches a speed of 28 in first 15 seconds. So when we mark the axis, here, like this is 10, 11, 12, 13, 14, and 15. This one is representing 15. So they mentioned from 0 to 15 seconds, it reaches a speed of 28. So what is the speed? 28. Each box is 121, 2, 3. So this will be 28, like 2 boxes below 30. So when it is 15, the speed is 28. And they mention here that it moves at a constant acceleration. If for a speed time graph, how we represent a constant acceleration? So we draw a straight line. So we'll draw a straight line till 15 seconds and the speed is equals to 28. The next part, from 15 seconds to 32 seconds, the car move at a constant speed. So from 15 to 32, so this is 31 and this one is 32. So from 15 seconds to 32 seconds, it continue to move at a constant speed. Constant speed means like speed should not change. So it is the constant speed. Then from 32 seconds, the car decelerate with a deceleration of 2 meters per second square until it stops or it comes to rest. But we don't know how much time it will take to stop. So how to solve this? First, we'll try to calculate the time it will take to stop. So we'll use a formula for acceleration. The acceleration is change in velocity divided by time. Or time is equals to change in velocity divided by acceleration. You can substitute the value first and then solve. So what is the acceleration or deceleration? That is 2. Or we can write -2 because it's a deceleration, so -2. Even with 2, you will get the answer, but that will give a negative answer of time. So example I'm taking as 2. What is the final speed? As I mentioned here, it comes to rest. So the final speed should be 0. What was the starting speed when it start to decelerate? It start to decelerate at 28. And we need a time. So we just cross multiply, time will be there in numerator and 2 will be divided. So 28 divided by 2 means it will take 14 seconds. So means from 32, like once it start to decelerate, how much time it will take to stop? It will take 14 seconds to stop. So from 32, if we add 14 seconds, that will be equal to 46. So 41, 2, 3, 4, 5, and 6. This is 46. And it will have a constant deceleration. When there's a constant acceleration or deceleration in a speed time graph, it must be a straight line. So what we'll do, we'll draw a straight line until 46 seconds. Is it clear, this question? How we worked out the graph for a motion of this object, which is first having a constant acceleration, then a constant speed, then a constant deceleration. For a constant deceleration part, we have to work out how much time it will take to stop. And from that time, we just extend the graph. Because it's a constant acceleration or deceleration, that's why even for acceleration part, it was a straight line, and deceleration also, it was a straight line. And constant speed means no acceleration, so it will be a horizontal line. Moving on to the next question. Define acceleration. How we define the acceleration? It is increase in speed or velocity per unit time. Like how much speed increases or velocity increases every second, we call that as an acceleration. Or if it was deceleration, you can just simply change the term in the word increase to decrease. Figure 1.1 shows a distance time graph for the journey of a cyclist. Describe the motion of the cyclist. So the motion of the cyclist is divided into 3 parts. Remember, a distance time graph, the slope represents the speed of an object. So first, from 0 to 15 seconds, from 0 to 15, the speed was increasing. Then 15 seconds to 30 seconds, the speed was constant. And from 30 seconds to 40 seconds, the speed was decreasing because the slope is decreasing. So what we can say, the first part, we can say that the speed is increasing. And when we say speed is increasing, we can say it is accelerating. From 15 to 30 seconds, it is a constant speed. And from 30 to 40 seconds, the speed is decreasing or it is decelerating. The next part, calculate the average speed and the maximum speed. How to get the average speed? If you want to work out the average speed is the total distance over total time. So what is the total distance traveled? 300. And what is the total time for the journey? 40. So if you are working out an average speed, so total distance is equals to 300 and total time is 40. So when we divide, it will be 7.5 meter per second. That's an average speed of the journey. But if they ask for actual speed, like the maximum speed, the next part is calculate the maximum speed. So how we can work out the maximum speed? First, we have to identify which region it will have a maximum speed. So from 0 to 15 seconds, the speed was increasing. Then 15 to 30 seconds, the speed was constant. And from 30 seconds to 40 seconds, the speed was decreasing. So which part it will have a maximum speed? This part it will have a maximum speed. So what we can do, either we can take out the gradient of this part. It's a straight line. So we can take out the gradient of this part and that will give us a speed. And we call that as a maximum speed. So first point on x-axis is x1. First point on y-axis is y1. Second point on x-axis is x2. And second point on y-axis is y2. So we take x1, x2, y1, y2. And we use a formula of a gradient y2 minus y1 over x2 minus x2. So y2 is how much? 250. Y1 is 70. And x2 is, this is x2, which is 30. And x1 is 15. So we simplify. This will be 180 divided by 15. So 180 divided by 15. This will give us the maximum speed. Why we specifically select a region? This region is because that's having the maximum gradient. The region which is having a maximum gradient will have a maximum speed. So the maximum speed will be 12 meter per second. So that's a maximum speed. Is it clear, this part? How we work out the average and the maximum speeds?
Yes, sir.
Moving on to the next question. A rocket is launched vertically upward. So a rocket is there, which is launched vertically upward from the ground. The rocket travel with a uniform acceleration from rest. After 8 seconds, the speed of a rocket is 120. What is the acceleration? So how to calculate acceleration is a change in velocity divided by time. What's the final velocity of a rocket? 120. Initially, it was at rest. And how much time it took? 8. So it will be 120 divided by 8, which is equals to 15 meter per second square. So acceleration of the rocket is 15 meter per second square. Or you can also say ms minus 2 or m slash s square. Figure 1.1, draw the graph of the motion of a rocket in first 8. A rocket is launched and you can see it is having a uniform acceleration. Uniform means constant. So if you want to draw or show a uniform acceleration in first 8, this one is each, like 10 boxes equals to 5, so each box is 0.5. So this will be 6, this will be 7, and this will be 8. And 120, 10 boxes equals to 50, so each box equals to 5. So 110 and 120. So we mark a point at 8 second speed was 120, and they mention it is a constant acceleration. So speed time graph, how we represent a constant acceleration? We draw a straight line, which shows it was having a constant acceleration. Then use the graph, determine the height in 8 seconds. So how we work out the height in 8 seconds? Basically, the height or the distance traveled by the rocket. Because like how much distance traveled by the rocket is the height gained by the rocket. What distance the rocket will travel vertically, that will be equals to height after 8 seconds. So if you want to work out the height after 8 seconds, we just find the area of this part. And what shape it is making a triangle. So we'll use a formula half base into height. So half base is equals to 8 and the height is 120. So we simplify, this will be 60 multiplied by 8. So 6 multiplied by 8, 48. So 480 meters will be there. That's the height of the rocket after 8 seconds. So whenever you need a vertical distance or horizontal distance from a speed time graph, you always take area under the graph. The next one, from 8 seconds to 20 seconds, the rocket rises with increasing speed but decreasing acceleration. And from 20 seconds to 15 seconds, the rocket has a constant speed less than 200 meter per second. On a figure, draw the graph. So from like first, we already did for 120, like when it reaches a speed of 120 after 8 seconds. So it was a horizontal, like straight line passing through the origin. That was a constant. Now, they mentioned from 8 seconds to 20 seconds, the rocket is having an acceleration. Like rocket speed is increasing, but the decreasing acceleration. Acceleration is decreasing. So how we represent a decrease from 8 to 20 seconds, it is a decreasing acceleration. How we represent a decreasing acceleration? So this is 20 and the speed is less than 200. So any value you can take, but it should be less than 200. Any value you can take as they did not specify. So this shows that the acceleration is decreasing. And then the third part from 20 seconds, it continued to move with a constant speed. From 20 to 25, the rocket has a constant speed. So from 20 to 25, we just draw a horizontal line to show that its speed is constant, not changing. But this, it should be less than 200 as they specify that the speed it does not exceed more than 200. Is it clear this part? How we complete the sketch, the graph? Moving on to the next question. A bus travel at a constant speed. So there is a bus which is a distance time graph. What slope represent? The slope represent the speed. So first it's a constant speed. So if it's a constant speed, it will be a straight line, constant gradient. Then it stop for a short time. So stop for a short time. Horizontal line, because when distance time graph, when object stop, the horizontal line will be there. And then it will accelerate, like it travel at a higher constant speed, so speed higher. So how we distinguish higher and lower speeds? We distinguish by a gradient. Like the second line should have a greater gradient, or it should be much steeper than the first straight line. So this shows that first it was moving at a constant speed, then rest, and then higher constant. In part B, a lift or elevator starts from a rest at the ground floor, and speed time graph for a motion of a lift to the top floor of a building is shown. Use the graph to determine the distance from a ground floor to the top floor. So if speed time graph is there, we need the distance. So we always take area under the graph. You can divide this figure into three parts. A triangle, the first one is a triangle, then rectangle, and then another triangle. So find the area of this part, which will be half. Base is how much? It is each 10 boxes equals to 5. So each box is 0.5. So this will be 5.56, 7, and this will be 7.5 because this one is 6. So 7.5. So base is 7.5. And how height? 10 boxes equals to 1. So each box is 0.1. So this will be 3.1, 2, and 3. So height is 3.3. So half base into height. Then the second one, it is from 7, like for a rectangle, 7.5 to 20. So this is 12.5 is the length. And height is 3.3. And for the last one, half base is equals to 5. And height is again 3.3. So we find the area of the two triangles. Plus, we'll add the area of the rectangle, and the total distance travel will be equals to sum of the all areas. So when we add them, it will be about 61.8, I guess, which is about 62. So 61.8 and unit will be meter because the speed is in meter per second and time is in second. So speed time graph, whenever you need a distance, you always calculate area under the graph. In question 8, figure 1.1 is a speed time graph for an ice skater. What is meant by deceleration? What is the meaning of deceleration? Deceleration means decrease in speed per unit time. Like how much speed decreases every second, that is called deceleration. Then a distance traveled from 3 to 6 seconds. A speed time graph, if we need a distance travel, we use area under the graph. So from 3 seconds, like this is 3, and this one is 6. So from 3 seconds to 6 seconds, we need the distance travel. So we use area under the graph. So we have to take total area of the graph. It's not like only a triangle. It will be a triangle plus rectangle. So starting from 3 and ending at 6. So this is 3. And height is how much? This is 5. So 3 into 5. And what about area of this part? Half. The term deceleration means the decrease in speed in unit time. If you want to calculate the distance travel is area under the graph. So it will be half base into height for rectangle for triangle. So half, what about the base? It is starting from 3 and ending at 6. So base is equals to 3. And what about height? It is starting from 5 and ending at 11. So it is equals to 6. So it will be 18 divided by 2 equals to 9 meter, and 3 multiplied by 5 equals to 15 meter. So what is the total area? So 9 meter plus 15 meter, or 9 plus 15, that makes 24 meter. So this is equals to 24 meters. The deceleration between 3 seconds and 6 seconds. From 3 to 6 seconds, if we need deceleration, first we check whether it is a straight line or a curve from 3 to 6 seconds. So this is 3 seconds and this one is 6. So 3 to 6 seconds, it is a straight line. So when it is a straight line, if you want to calculate an acceleration or a deceleration, there are two ways. Either you can use formula, or if it is a straight line, either you can use a formula or you can use a gradient. It's up to you. Both will give the same answer. If you use a formula, it is v minus u over t. If you use a gradient, y2 minus y1 over x2 minus x1. So like first previous similar question I solved by formula, this one I'll solve by gradient. So we take 2 points. The first point, like starting point, and we draw a line on x-axis that is called x1. So this first point is known as x1, which is equals to 3. The second point you can take any 2 points, but we need for 6 seconds. So the second point, that is equals to x2, which is 6. Then first point on y-axis is called y1. That is 11 here. And the second point on y-axis is called y2, which is equals to 3, which is equals to 5. We use a formula for gradient, which is y2 minus y1 over x2 minus x1. So y2 is how much? 11. Y1 is 5. X2 is equals to 6. X1 is 3. I just switch. Y2 is actually equals to 5 and y1 is 11. So when I simplify, it will be minus 6 divided by 3. So minus 6 divided by 3, that's equals to minus 2. And the unit will be meter per second square. So if we have a straight line for a speed time graph and we need an acceleration, we can use a formula. Expression is change in velocity divided by time, or we can work out the gradient of that section. That will give us the deceleration or acceleration. So it will be 2 here. What happened to the size of deceleration after 6? And what happened to resultant force? Look, the deceleration refers to the angle here. It was a straight line. When it is a straight line, it means there was zero acceleration or deceleration. For this section, it was a straight line. What it shows the acceleration was or deceleration was constant because it is a straight line. And then the angle is decreasing, like it's getting less steeper. It become more horizontal or become less steeper. So here what happened to acceleration or deceleration? It will decrease. Like the magnitude of a deceleration will be smaller deceleration. So if the deceleration decrease, it means the resultant force will also decrease because deceleration and resultant force are directly proportional. So this part, they ask what happened to the size of the deceleration after 6 seconds. So the size of the deceleration will decrease. And what happened to the resultant force after time 6 seconds? Because the deceleration is decreasing, deceleration and acceleration are directly proportional to resultant force. So the resultant force will also decrease. Is it clear this part?